Okay, everybody, thank you for coming to IndEx webinar number 6. We do weekly webinars on everything to do with hazardous areas and perhaps on other subjects that are not touched upon. My name is Michael Marrington. I am the General Manager of IndEx. If you should have any questions during the presentation, please keep it short. May answer it, but all long form questions will be answered at the end of the presentation. Okay, so EXD. What is EXD? What are the two different types? And let's talk about all the different considerations and perhaps new ideas. So some of you may have seen this test. This is an example of an EXD enclosure with gas around it and a fault introduced to then allow an explosion to happen in a controlled environment. Now, what is EXD? Well, the principle of it, it's a bomb-proof safe. It contains the explosion within the box. It does not stop hazardous atmosphere, gases, or vapors from entering. But should there be an explosion, an arc or spark which causes an explosion, the construction of it is it will contain that explosion sufficiently where it will not crack, but the overpressure will be allowed to bleed through a specifically designed gap, the flame path gap. Now, by that gap being really small, any of the particulate carbon from the explosion, it will not squeeze through that gap. Also, by the hot air going through that gap, the body of the EXD device then acts as a heat sink. It sucks the heat completely out of that gas-air mixture so that when it goes outside, it will not be sufficiently hot enough to ignite the external atmosphere. Now, when we're looking at EXD devices, we have multiple different marking possibilities. You got EXD, DB, DC, XP, which that'll be explained later, and you may have other techniques like DE, DEM. Now, the history of it is this came out of coal mine explosions back in the early 1900s. This was the first EX protection technique. Now, it was originally used for group 1, 2, and 3, or in North America, class 1, 2, or 3. So the whole point of the EXD device is to limit the surface temperature and to not allow escape of an air-gas mixture, which would be hot enough to cause ignition of the external atmosphere. Okay, so a good way to think of it is it's a bomb-proof safe, a heat sink, and it contains anything bad that can happen inside. So what can happen with an explosion within the box? Well, it can propagate up the cable. That flame will go up or through anything that it can. So this is an example of it going up between the cores in a cable. So it's important to maintain its protection technique. Have all the bolts in, use the proper glands with the proper cable, or use barrier glands, and use high quality cable. If your cable's not circular and compact, this could happen. Now, when we talk about flame path types, well, we have 3 traditional ones that we know about, and a 4th one that's more for rotating equipment. So we got flange type on the left here. In the center, we have threaded type. And then on the right, we have spigot. Now, for labyrinth rotating equipment, you have to concern yourself with a rotating shaft. So if you look here, where I've drawn in red, a labyrinth is like a maze. It slows down the explosive gas so that it sufficiently cools. And once again, it is a very small gap where particulate, such as arcs and sparks, cannot go through. So we have a question. What is not restricted from entering an EXD device? What does an EXD device not stop from entering? Once we get up to about 80 or 90% votes, I will close the poll. So what does an EXD device not stop from entering it? Keyword, what does it not stop? About 60% voted. Give it another 10 seconds. Okay, closing the poll. We'll share it. Now, let me tell you, an EXD device has to have a minimum IP54 rating. 5 for dust, 4 for water. EXD devices do not stop gas, vapor, or humidity from entering. Okay? So yes, it does stop dust and water from entry because, well, ingress protection, creepage and clearance distances, water and dust can cause arcing, sparking, which could cause an explosion. We don't want explosions to happen inside. If it happens, it needs to be correctly tested, certified, and maintained, but it does not stop gas or vapor or humidity from entering. So the answers of dust and water, that is not correct on those ones. Okay. Now, when we look at this device, this is a flange type device. We'll ask the question, what gas groups can this device be? So this is a hinge type flange EXD enclosure. Multiple answers. Hinge type EXD flange. So about 50% voting. About 70%, give it another 20 seconds. Okay, so with the hinge flanged type EXD device, you cannot be group 2 or group 2C It cannot be rated for those gas groups. This was covered in our weekly webinar, IndEx Online webinar number 2. 2C requires a very tight gap, which is not being capable of being done on a flange type enclosure. 2C with a flange type enclosure is a very small enclosure, but a dead giveaway on flange type if it is hinged, it is 2B plus H2 or less. So these are the trade knowledge that is being shared with you. If you see a flange type with hinges, probably not 2C or group 2. You're looking at a 2B plus H2 or less. So, next one. Now, think of the last question, but this is a spigot type. Let me go back. So a spigot type enclosure, you may have seen it there for a moment, but it's not a flange type. What gas groups can a spigot type enclosure be? Multiple choice, so you can put many answers. 48%. So if you have a spigot type enclosure, what gas groups can it be? Is there any restrictions like flange type? Only one answer for selection. Sorry about that. So basically, there's one answer that answers it all. That would cover all of them. Sorry about that. Okay. So the correct answer would have been, I should have made these all completely multiple choice, and the answer is all of them. Now I'll show you the enclosure. This enclosure may look like a flange type, but get my laser working. If you look at the edge here, it goes into the enclosure. This is a spigot type enclosure. So the difference is on this flange type flat surface, within the standards, the restrictions are a very small enclosure for 2C, something of this size, practically all EXD flange types with hinges are 2B plus H2 or less, while an option is this enclosure is the construction of a flange type enclosure with a 2C gas rating. So the spigot design allows it to do that. Now, rotating equipment. You have multiple flamepath locations. On the right, you have the drive end and non-drive end, plus where the terminal box makes connection with the motor. Once again, on the rotating shaft, you will have labyrinth or other type of design for flamepath, and then the terminal box up here, if it was a pure EXD motor. Now, when we look at EXD, there's many different options of how it can be made. When people think of here in the center, all these different control stations as EXE and D, The D portion of it is the inside switch. Yeah. Within these pressure switches, within these switches, the terminals are EXE, but inside of it is EXD. Then we have the typical EXD enclosure. Then we have EXDE panels, which allow the use of not having to use a barrier gland. They have line bushings. There's different types of EXD, how it is utilized. EXD panel, EXDE panel. Now, when it comes to flange type, when we put it close to a solid object, we're told that you have to have a gap of 10 millimeters for 2A, 30 millimeters of 2B, and 40 millimeters for 2C. Now, I have a question. What if you have two flange types right next to each other? What would the distance between them have to be? So, see if I can find that 1 second. If two EXD, 2C devices are next to each other, what is the required distance between them? EXD 2C. %50 voted, give it another 30 seconds. %81% and closed. Okay. So the 8% that said 20 millimeter, no, that is not correct. So you refer to the standard 60079-14, 14.2. That's not one of the answers. The answer of 60 millimeters, that is also incorrect. The answer of 30 millimeters, no, that's for 2B. The direct interpretation of the standard is 40 millimeter. But it has not been thought of or evaluated by those who have perhaps created the standard. There seems to be no indication where if two of the same devices are right next to each other, that an explosion happening, I've heard the excuse of that it will not happen in both devices at the same time. We do not know that. That testing has not been done. We also have not had the testing done to show what impact two explosions going on and the hot gases being released and impacting each other. So that would involve thermodynamics. So a safe bet and also a good bet for human factor engineering, accessibility for your people to get their hands on glands and parts and bolts. 80 millimeters is a nice one, perhaps for the end users to put into their specifications. Perhaps an item to touch on in the future, in future standards. Now, when we talk about gaskets or O-rings, this is an issue that few seem to understand where the flame path now applies. So the gasket or O-ring is used to increase the IP rating or change its NEMA rating or UL type. The flame path does not include the gasket. And the flame path is either before or after the gasket, depending where it's installed. So everywhere that I've highlighted on the left here, left of the gasket is the flame path, if that was a flange type. But if that's a spigot type, hard to tell from the picture, it could be this section here. On the threaded enclosure, it's only the threads, not to the left. On that edge is not a flame path. Same thing with all these other pictures. The flame path on this one is the complete L. But on this one, the flame path is inside, after the gasket. So if the area damaged after or before, if the area is damaged, but it's not, is it the flame path or not? We have to know the location of the gasket. Take a look at these images, take a look in the standards. Now, when somebody mentioned having a box between these two devices, we're talking about two independent EXD panels, devices, not ones that are interconnected, okay? So be aware that the gasket is not the flame path. It is not part of the consideration of the distance for the flame path. It is for increased ingress protection. So we have three different examples here. If I put up the question, one second. Let's launch the question. So the question will be for the one on the left-hand side. What type of flame path is that? %63 voted. Give another 10 seconds. Okay. So if we were to actually ask this question of all these three, the correct answer is flange. Hinged spigot types are rare. It's definitely not threaded, and it's definitely not labyrinth type. So these are two different types of EXD, actually, which we'll come up to perhaps in an upcoming slide. Okay, so the two different types of EXD. Now, within the industry, for those that have worked in North America and overseas, or perhaps worked with both types of equipment, maybe some have figured this one out. But there are two different types of EXD: explosion proof and flame proof. Now, the word explosion proof is used incorrectly throughout the industry as meaning all of EX, all of hazardous area equipment. If you use the incorrect terminology, you're going to cause confusion. Explosion proof is covered under UL 1203 or FM 3615, while flame proof is covered under the standard ENIC 60079-1. So the differences between them. Well, for explosion proof, it's rated for all the gas groups and dust groups within North American system, A, B, C, D, E, F, G. Under flameproof, it's only good for gases and vapors. Now, the construction of them is very different. There's minimum wall thicknesses for explosion proof. There are none for flameproof. Explosion proof really is a bomb-proof safe. It is significantly heavier. Also, there are different construction considerations for the gaskets, the joints, the gaps, the holes, the accessories, the plugs, the fittings, conduit systems, rust protection, and extra performance tests. The testing is more onerous and different for explosion proof. Now, the testing differences. Explosion proof is tested with the conduit system attached. Now, the barrier, the seal, will be 18 inches, 450 millimeters away from this device. Testing is conducted at the same time for the reference pressure and flame transmission test. Flameproof does not have any of those tests done. The acetylene and hydrogen testing on these devices for explosion proof requires a 75% reduction in the gap, I should say, of the flame path joint. Drilling for flameproof can only be done by the manufacturer or a repair facility. An approved repair facility approved by IECEx certification facilities scheme, or the manufacturer's approved repair facility. For explosion proof, I can drill it as the contractor, I can drill it as the end user, and I can drill it in the field. But for flameproof, it can be NPT and metric threaded entry. Explosion proof can only be NPT. Now, ingress protection. Everybody likes to say that ingress protection is not part of 60079. I disagree. The word and the standard is brought up very much, but the testing requirements are found in a different standard. For explosion proof, those ingress and weatherproofing requirements are part of the standard. Now, test pressure. Well, it's 1.5 times the maximum for flameproof, while it's 4 times for explosion proof for 10 seconds. Now, for flameproof, there's 5 tests done, 5 explosion tests done with each different gas mixture, 2A, 2B, 2C. Yeah, they choose the most dangerous gas and test at that. If it's good for 2C, it's good for 2A, 2B, and all the other considerations. Now, for explosion proof, there's 10 explosion tests, but when it has a breather, they do 10 further tests with that breather 75% blocked. Now, heat rise. They don't really consider it for explosion proof because it's a big, big heat sink. It can absorb a lot more heat and not be as hot on the outside as a flameproof because it's thinner metal. So it limits its components inside. So you can have higher wattage devices in an explosion-proof enclosure compared to a flameproof. Now, can you sell an empty enclosure? Can you receive an empty enclosure as an EPC? Well, for explosion-proof, you can. For flameproof, you cannot. Only if you're a manufacturer. You're planning on putting your own devices in there and then having the box independently certified. So, explosion-proof and flame-proof, the only thing they have in common is they're both called EXD. All the other considerations, there is so many differences, Okay, next. Let's see if I can give you a question. Let's ask you a question about that motor we looked at before. Does the inspector inspect all the flame paths? So this is multiple choice, but I've made it where you can only select one. So when you think back to the motor and the multiple different types of flame paths, does the inspector inspect all the flame paths? Multiple correct answers, but choose the most relevant answer to you. %. Give another 10 seconds. Okay. So when looking at a motor, do they inspect all the flame paths? If it's on site, no. The inspector does not inspect all the flame paths. He cannot. He's not taking off the C face or the fan end and taking the fan off. He's not taking the terminal box off. He's taking the terminal box cover off. So he can't get at everything. Now, the manufacturer or the repair facility, yeah, they would be the one inspecting every single one, because that's their responsibility. Now, when it comes to only the terminal enclosure, that's what the guy in the field would be inspecting. So the two most correct answers would probably be the bottom two. But purposely made it this way so it's open to interpretation. I want to get people's opinions. Now, when we look at common damages of EXD devices, well, there's many. Corrosion, water ingress is a big problem, whether it's in the device or not. Rust, damages on the edge. Probably came from somebody with a screwdriver. Then we have other ones where it looks like pitting, old age, other things going on. A weird combination of a putty and liquid barrier glands somehow. Glands completely rusting away. And then damaged edges, perhaps of dropped covers or dropped boxes. So here's an quick little example of testing. So that box was filled with a flammable gas and they applied a small little spark. Just to show you that even a small bit of gas can be dangerous. Now, key documents and tools to have. Now, what do we need? Well, the three most important documents that anyone would need would be the certificate, whether it be IECEx, ATEX certificate declaration of conformity. That takes the #1 precedent. That document matters most. #2, the manufacturer's IOMs, their installation, operation, and maintenance manuals, their data sheets. Then the standards and client specifications. Now, if the certificate, the IOMs, and the standards contradict each other, you choose the certificate. You must always meet the requirements of the certificate. If the certificate and the IOMs go against the standard, that does not matter. You apply what the certificate and the manufacturer's IOMs meet. The hierarchy of documentation you follow is in that order, but client specifications may be on top of, but sometimes they invalidate what the certificate or manufacturer or standards say, that is an issue for the end user, hopefully for them to correct. Now, tools. Without these mentioned tools, how are you installing, maintaining, and inspecting your EXD equipment correctly? You wouldn't be. Correctly. Incorrectly, yes. So, what do we have? Well, feeler gauges, torque wrench, verniers, calipers, pin depth gauge, and a non-hardening grease. Now, so if I ask you a question, if I scratch a flame path, can I measure that scratch? So if I'm just a technician, an inspector, can I measure a flame path scratch? %67%. Another 10 seconds. And close. Okay. Unfortunately, 56% of you think that you can't measure a flame path scratch. Let's go back and I'll show you the answer. It was on the images I showed you. So the tool that you would use to measure a flame path scratch would be a pin depth gauge, calibrated, approved by the end user. This is the tool you measure to measure a scratch or a pit or dent within a flange type or perhaps spigot type flame path. Okay. Here's another demonstration. This is a NEMA type North American enclosure. So all the bolts are installed, correctly torqued, no scratches. So that explosion, I don't know if you guys saw it at the end there, happened due to one or two bolts not being installed, or bolts were backed off and not sufficiently torqued. So the gap in the flame path was too big to stop any particulate from going through, or to sufficiently cool the gas that was then escaping. Now, another important consideration is greasing of your flame paths. If you do not grease your flame paths, you're probably going to have issues with ingress protection, rusting, perhaps dissimilar metals, especially after explosions. 60079-14 talks about if flame paths shall not be painted. Talks about using a non-hardening, non-setting grease, and it's the ultimate responsibility of the end user. The likes of Chevron, the likes of Exxon, they make the decisions. Now, why, if we go back to the tools, Why are we using a torque wrench? Why are we using feeler gauges? Why are we using a pin depth gauge? Well, the only way to measure a flame path is you have to compare it to the tables in 6079-14, or sorry, -1. One of those ones. -1. These tables talk about the approved gap, the minimum width of the joint, and the gap between the cover and the body of the EXD device. So I'm pretty sure that gap would be important to figure out during your inspections. Every single inspection, when you're doing a close inspection, if you're not using feeler gauges, you are not confirming that these gaps are maintained. Has the box been torqued too much? The bolts, or are they too loose? The only way to check that would be the feeler gauge. Yeah. Then you would check for tightness of the bolts with a torque wrench, because you don't want to over torque it. Checking the width of the flame path, you would use the vernier calipers. And if there's any scratches or dings within the flame path, you would use a pin depth gauge. And the resource of information you would use is the certificate, the manufacturer's IOMs, and directly straight out of the standards, because all this information is called for. Now this is for 2A, 2B. This is for 2C. Yeah. Take a look at the bottom here. They've started to incorporate historical data from the US on Class 1, Division 1 explosion proof gap dimensions. So the word explosion proof is North American EXD. Is there a permissible scratch depth? No, but there's a permissible gap here. So if the gap for your device is 0.5, let's say 0.2 millimeters, but your box actually has a gap of only 0.1, perhaps if you had a scratch that only went another 0.1, would that be okay according to the standard? Well, it wouldn't be going over the 0.2, it would be exactly 0.2. So think of that gap. If you make any valleys, you're making the gap wider. You can at least measure with a pin depth gauge how much wider your gap is, the valleys, the scratches, and with the vernier, you can measure how long it is. Now, going by opinion doesn't mean anything. With those tools, you can at least verify with use of the certificate, IOMs, and standard with a legitimate tool that has been calibrated. So cylindrical and tapered threads. There is other considerations. Be aware of this. Inspectors only work to 60079-14 and 17. Torque settings are generally on the CERT or IOM. Correct, but 14 is for inspection. So if those torque settings have been done correctly, well, then the previous ITR inspection test report shall be cited by the inspector. Now, if we're talking about operations and maintenance, that person has to know how to open and close that box correctly, or the protection technique is null and void. If you don't tighten all the bolts correctly, if they're too loose, that's a problem. If it's too tight, you can damage the walls of the cover of the enclosure. You can warp it. This is a bomb-proof safe. We're using the feeler gauge there to make sure that the cover on this threaded type enclosure is sufficiently tight. Now, during a close inspection, if you're not using a feeler gauge, you're not doing a close inspection. You're not doing a legitimate close inspection. Correct. When we talked about the different constructional differences between explosion proof and flame proof, they're called for in different standards, so they're not the same. So how would you test this box? On a threaded type, you would use the feeler gauge. And obviously there's a specific tool to pick up those two holes that the manufacturer would give you, and that would be the correct way to torque it in this instance. But a flange type, you would use a torque wrench and you would use the feeler gauges. Even before you open it, you would use feeler gauges. You need to see what the condition is before you even open it. And then use it afterwards to make sure you've closed it correctly. Now, the big explosion that everybody saw. You might not be able to hear this, and it might be a little bit laggy. If it would play. So this is an explosion-proof enclosure. This is not a flame-proof enclosure. They've installed the window to allow you to see the testing. So they've surrounded it with gas atmosphere. This is when they've sufficiently tightened all the bolts, not over tight, not too loose, and no damages. Here's a very minor scratch. Very minor. And it causes that. Now, I've shown this video to certain project managers, and the response was, that'll never happen to us. I've never seen this happen. I've never heard of this happening. This won't happen to us. Human nature is the biggest fault, human-induced faults. The whole reason for our hazardous area industry, it's higher quality industrial equipment. Yeah, it's independently tested and certified because we've had history of multiple explosions that kill people, that destroy facilities. So, I'd like to give you guys awareness of our EX Museum. It shows the past, present, and future in explosion safety, not explosion proof, explosion safety technology. It was founded by Stahl, Hungary, and it presents the objects and equipment that accompanying the history of explosion safety technology. So I just want to show you some of the things that we have at our facility in Budapest, Hungary. So on the left there, we have old EXD phones that actually have external speakers or horns. In the center there, we have multiple different types of flanged type of equipment, switches, terminal boxes, things like that. Top right, big old EXD lamp. And then on bottom right, we have control switches, proximity switches, or limit switches, I should say, on some of them. We also have motors and things like that. Now, new ideas. This is something that I came across about 2 years ago. There's a manufacturer, Stahl, that is creating a EXD enclosure that is, I think, 60% or so lighter than a traditional EXD box. It actually has a pressure relief. So we'll show a quick little video. This is second to last slide. And then we'll open it up to questions for everybody. So it's a good video to show that when there's an explosion inside, that heat, pressure, particulate matter is stopped. The particulate, the matter is stopped by that mesh screen, and those screens cool down and slow down that explosive pressure. So it's, 50% lighter than a traditional box. It's been approved by 2 ATEX notified bodies, 30 patents going on. So just wanted to give people an idea that there is new ideas. Yeah. So when people think of big EXD enclosure, big panel, that's not always necessary. There can be EXDE. And actually, when it comes to this is EXS, special, but it does incorporate the ideas of EXD, I should say. So when it comes to EXD, there's new technologies coming, but there's a lot of old ideas. So when we go back to the old ideas, obviously EXD is continuing to be used because it's well trusted and well understood. And then there's new ideas that are coming that perhaps will, some clients will find that useful. Now, what is the difference between EXD and DE? So let's go back. Use my presentation to show you guys the difference to answer your questions. Now, right-hand side, EXD panel on the bottom. Yeah, well trusted. EXDE panel allows for all the entries to go into an EXE compartment. No need for barrier glands. So it significantly reduces the size of your EXD portion of the enclosure. You don't have to enter your cables into the EXD enclosure. All the wiring, pre-wiring, has been done. So the advantages of that is it's quite easy for installation and maintenance. Well, an EXD enclosure, if you have a big control panel and you're opening and closing it, there's a greater chance that you could cause damages to it. The more you touch something, the more chance that you make a problem for something. Okay. Thank you for your questions, guys. I'm just going through. We're having explosion proof only in joints or other joints. So explosion proof has 4 different joint types: threaded, spigot, flange, and also the labyrinth for rotating equipment. What is the difference between testing component for a U and a full certificate? The U certificate is just an empty enclosure. That empty enclosure for testing, it doesn't have a temperature rating yet. It'll have a gas group, but it won't know that, you won't know the temperature rating until the equipment has more equipment installed. And then while it's under load, yeah, during factory acceptance testing, they would put it under load, 100% load, and perhaps apply faults and see what temperature that device can get up to. Then they would certify to what temperature that would be good for and any other conditions of use. Can you say the difference between explosion proof and flame proof in simple terms? Let me share a question. I should say, can all EXD equipment can be installed in any location? Yes or no? If I had an AEX, American EX explosion proof device, Can that be installed in an ATEX country or country that requires IECEx equipment? %60 voted. I would love to get up to 90% voting on this one. 70%. We're just going to let this one go a little bit longer because this one really needs to be answered for people. 80%. Okay, gentlemen, explosion-proof equipment is tested and certified differently than flame-proof. They cannot be mixed and matched. If the end user wants to do a fitness for purpose assessment, that's their choice. But us as installers and inspectors or designers or procurement people, no, they cannot. Even AECEx equipment approved for classes and zones are certified and tested to a national deviation for America. If you were to install American equipment in other areas in the world, whether it be explosion proof or American flame proof, you are putting the end user at financial, reputational, and perhaps occupational health and safety risks. If you're the EPC and you're choosing this equipment, please be aware of these concerns. As we pointed out, there is significant difference between explosion proof and flame proof. They are not equal, and one is not better than the other. They are different. Can you please explain again the requirement for choice of cable glands of NPT, metric, or without barrier? That might be another webinar. In our last webinar, we showed how cables make for great conduits. Water and gas and vapors go up cables all the time. No cable is circular and compact where it can stop the passage of gas. And then when we talk about flames, that's another thing. When the test is only 5 seconds, is the test long enough? If it was 30 seconds, would it pass? Difference in temperature, pressure, what type of gas, what were the size of the atoms of that gas? These things have not been clarified. Now, when we talk about explosion proof and flame proof, we'll pull that up since somebody asked about the glands. So explosion proof is only NPT. Flame proof on the right can be NPT or metric. For explosion proof, it's a barrier gland every single time for a cable. When arcing and sparking equipment, In Canada, if it's EXD, it's always a barrier gland, full stop. There's also the barrier gland selection table, which the UK follows, which some countries follow, but the international standard has changed. This is a contentious issue. Is the threaded entry considered part of the flame path? In flame proof, the thread is a flame path. In explosion proof, it's not thought of that way, but you still obviously, NPT is a wedge type design. You better grease that flame path, that threading. How about pressure piling? Yes, another issue we could talk about, but we only had so much time. Pressure piling. Explosion proof boxes, you can put anything you want into them. Almost, as long as you follow the manufacturer's requirements. Flame proof, what comes in it is what is only what you can accept. You cannot change any part unless it's like for like. Same make, same model, same certification, as per the certificate and the manufacturer's IOMs. So another one that Thorne from Stahl actually give good input is explosion proof is only for Division 1. EXD, Flameproof, is only for Zone 1. So when people say EXD, this confusion is going to continue because EXD is used for calling explosion proof and flame proof. And some trainers around the world continue to spread this inaccuracy. What is the safety distance of the new type of cabinet? We will pass that question on to the gentleman from Stahl. If he answers it, I'll give the answer. Can we use air purge panel in EXD area? In EXD, what? Okay, so sometimes you have an EXD motor, which it is so big that you need to purge the gas out of the enclosure before you start up the motor. So there are hybrid motors that are EXP and EXD. So part of their purge operation, before startup, they purge all the gas out as to not cause an explosion. So Zone 2 is equivalent to Div 2. That is correct. Are EXD light fitting enclosures tested the same as EXD other enclosures? Well, there's different test requirements depending on the gas type and the overall volume of the enclosure. So these tables talks about the widths and everything. So come down to the gas type, yeah, primarily, and also the construction of it. How to know the original component arrangement and what is the limit of changing this arrangement? The difficult thing on an old installation, this is hard to find. On a new installation, the EPC really should be pushing the manufacturer, Stahl, Bartek, whoever it is, for a general arrangement drawing, which lists all the internal components. Now for detailed inspection, does that inspector always have that drawing? Some EPCs and some end users don't give their personnel all the information. Time is money. So more time, less money. Does it require through the wall? Sorry, I don't understand what you're saying. Gap will vary based on volume. Correct. These tables here are talking about the maximum gap between the cover and the device, yeah, and the minimum width, and also on its overall internal volume, centimeters cubed, yeah, and also on the type of flange, yeah, cylindrical, threaded, flange, spigot. Shouldn't the grease be used on the flame path be a non-petroleum based lubricant that does not propagate out the flame path of the enclosure? Correct. So this is just my favorite type, okay? I'm not telling anybody that Cooper Cross Hines STL standard thread lubricant, it's lithium based. So it's got a high dielectric strength, actually gives you continuity between your cover and your enclosure, non-hardening, increases your rain tightness, doesn't increase your IP rating, it assists it. I put it on the bolts, the cover, and the threads of the gland. Where can we use any electrical parts in an EXD? In Flameproof, you can only use what has been tested and certified. You cannot change anything to anything else. It's only like for like, exact replacement. It's different, Ryan. Only if gas group T ratings are the same. Sorry, I don't know what. Too many questions. When a use certificate is supplied to a manufacturer, does the manufacturer need to certify after the assembly is over? Yes. Well, if they plan on creating a product, let's say you get an empty enclosure and then you add a PLC inside of it. Now they have a new product. They then have to send it to an EXTL and CB testing laboratory and certification body. Is it allowed more minor component? Is it allowed more minor components inside it? So minor components, I'm not sure what you mean. If it doesn't come as part of from the manufacturer, tested and certified with what's in it, you cannot change anything. For explosion proof, who can fix the final certification of the enclosure? So the final certification of the enclosure would be a nationally recognized testing laboratory from North America or one from Canada. So Canada and America, so you have lab test certification, QPS, UL, FM. The one we work with is lab test. They are the ones that can put on the final certification. My understanding is a plant can choose to install Article 501 or 505, but they should mix equipment to Article. I think that should say they should not mix. So yeah, there's NEC 500 and 505. NEC 500 is classes and divs. NEC 505 is classes and zones, AEX. So one would be explosion proof 500 and the other one would be flame proof 505, but it's American EX, AEX. If the equipment has an IECEx number for normal EX, but also has a UL listing for its AEX, yeah, NEC 505 considerations, then yes, that can be used everywhere in the world, but you have to be careful. And as for mixing them, really not a good idea. They are tested, they are completely different. They're just both called EXD, that's the problem. Why there is an EXD conduit if they are bearing an ATEX certificate with you, connecting the joint to EXD equipment, how is the inspector to determine? So for a conduit, they need to have a barrier within 450 millimeters, 18 inches. So the conduit is a wiring means. It does not need to be certified with the equipment. Under explosion proof, it does. How does the inspector determine this? Well, attend these webinars. If you need further training, we do IECEx, ATEX, and HAZLOC and EHA, Australian training. Wherever you are in the world, we can do it online. Now, as for the conduits, there are flexible conduits that actually have a U certificate. I don't have a picture of it, but think of an anaconda, sealed tight, but it's metallic braided. Is there a difference between the longitudinal and parallel scratches of flange? Yes, absolutely. If the scratch goes across the flame path, that is the most dangerous because then the gas can get out along that path. There are assumptions as to what percentage across is okay. Some people say 10%, some people say 20%. But how deep is that? Well, I would use the pin depth gauge. Yeah. As for going along the length of the entire flame path, the long distance, that's more contentious. Really hope you have a competent EX engineer. How to determine the power rating of an EXD enclosure? Does the EPC required to populate the power rating? No. So for EXD, if you're talking about flame proof, it is tested and certified. The manufacturer puts their equipment in it and it gets sent to an IECEx approved or ATEX testing laboratory and certifying body. For the explosion proof, they don't worry about the temperature so much, but you can have it done. Or if you just have terminals, you don't need to do anything. You can sometimes put whatever you want into it. Can you please explain the notified body certification steps? We do not have the time for that, but if you take a look at all the IECEx information on certifying bodies and testing laboratories, it's nearly the exact same, except for ATEX Zone 2. How to determine type of gland? Does the selection depend on the type of enclosure? It depends on the size of the enclosure, the gas group, but primarily I look at first, is the cable circular and compact, and does it pass gas or not? My interpretation of the standard is no cable stops the passage of gas. That's my interpretation, my own educated interpretation, okay? That's mine, not yours, but each end user is different. Each country has their own. The safest way to deal with glands in an EXD enclosure, bury glands full stop. That's what we do in Canada. When you use a liquid pour gland and a good quality gland, doesn't take that much time. Once again, follow the table, the specific table for gland selection, but remember, is the cable circular and compact? Is there a difference? 1 second. Where was I? Reading. There we go. How is the temperature rise calculated for an EXD DE enclosure in control panel? They do factory acceptance testing, or basically they take it to the laboratory, they apply 100% power and also induce certain faults. And after so much time, they take a temperature measurement. How they do it is in the standard 60079-1. If we drill a cable gland and explosion proof JB on site, is a certification required? Flameproof, you cannot drill a flameproof enclosure, okay? You in the field, you on site, you cannot drill it. You are not allowed. Certification, the safety of it is completely compromised. Do not do that. Please, do not do that. If it's explosion proof, that's a different story. But if you're using flame proof and explosion proof on site, you are at significant safety risk, okay? Do not drill flame proof enclosures. We drill cable gland for explosion proof on site. Now, explosion proof, yes, but we want to not confuse people. Once again, only explosion proof, and you must do as the manufacturer's certificate, their listing indicates, what their IOM state. Speak to the manufacturer, double check, have the proper drilling facilities. It's a dangerous thing if you don't do it correctly. Table you give is for -1, where only inspectors use is 14 and 17, how to assess the scratches. The standards are not perfect. Yeah, the standards are created by committees, usually of engineers, from manufacturers, EPCs, end users. They perhaps don't consider all these considerations. Perhaps they don't have the field experience of what you're dealing with. For EXD, for ATEX and IECEx, the same. Generally, everybody just manufactures and certifies their EXD equipment for ATEX and IECEx because they would be restricting themselves in their sales. So for knowing what you have to do for your piece of equipment, if you can't find the IOMs, check the manufacturer's website, like Stahl, that X pressure cabinet. If you wanted to learn more about it and find out where the certificate is, the certificate's on the IECEx website. Apologies. The enclosure has a certificate. The ATEX certificate would be with them. The IECEx certificate would be on the IECEx website, and their instructions would be on Stahl's own website, or the likes of Bartek, or something like that. Can we use uncertified components in EXD? You can't use it. The manufacturer selects it. So you don't select uncertified equipment. The manufacturer puts it in there. and selects it and has it tested and certified. Why EXD? So the D comes from a German word, which I'm forgetting right now, Druck something or other. I'm sure Gurgly can tell me later on. So the EXD comes from a German word. Can you give photographic examples in the mail of a rejected or accepted joints? Once again, it is subjective. What I accept is maybe not what you accept. If you want further consultation, we can assist. We have these experiences and have provided these services. EXD, according to IEC, can it be used in a dust environment? Now, EXD equipment actually used to be used. This EXD equipment used to be used in group 1, 2, and 3. In the recent standards, they've changed it where actually the same construction, you could probably certify this equipment, which most do, EX, D, and T. T is in Tom. T for dusts. But they separated those protection techniques to separate what is for gases and what is for dusts. EXD certified according to, are there any benefits in your opinion of using EXD instead of EXE? D instead of E, only for high temperature equipment, because EXE can't have any arcing, sparking, or hot points. Now, is there any benefits of using EXD over intrinsically safe? Yes. Intrinsically safe, maintaining the circuit is nearly never done. The calculations are done on the overall circuit, on the type of cable, on all the junction boxes, on all the terminals, on all the barrier, the end devices, and the simple devices. The moment anything is changed, does anybody actually go and redo the circuit calculations? Do they check the DSD, the detailed system, was it system detailed, yeah, the DSD, detailed system documents. Does anybody actually check over the calculations? The end user usually does not do that. Not all end users are the same. Some do, many don't. If you just change a cable, if it's not like for like, or you increase the length of it, your calculation may invalidate that intrinsically safe circuit. What is the difference between the equipment group and the gas group in the standards? Well, groups, you got group 1, 2, and 3. Underground mines or coal mines. Group 2, gases and vapors. Group 3, dusts and fibers. Some standards use equipment group as the same meaning as gas group. Well, group 2 equipment is only gas group. So if you said just group 2, that means 2A, 2B, 2C, 2B plus H2. Can we supply without internal wiring to end user? For flameproof? Yes. Without internal wiring? Well, if it's just a device that you have, you could have a device mounted in there just with terminals where they have to bring their incomers and outgoers cables. Yeah, you don't need the internal wiring. But if it's a flameproof enclosure and there's wiring that has to happen internally, generally the manufacturer would provide that, because you would specify to them what you need. If you're doing differently than what you specified to the manufacturer, you're nulling and voiding the certification. How to evaluate if the sealing barrier in the cable gland or the sealed component? That's a question for another time. Your barrier gland has to be 20 millimeters deep, 1 millimeter between each cores, and 2 millimeters from the edge of the cone. And best is a liquid pour barrier gland instead of a putty. Like IP certified equipment, would you share some videos on how to certify equipment? Yep, the explosion testing I showed you is some of it. We can share others. Giving a free hand to the end user to populate an empty explosion-proof enclosure. Is that not dangerous? Yes. Yes, it is. But I've experienced it in Canada before on a class and div installation. We had empty enclosures. We drilled the boxes. We put the terminals inside of it. But it told us how many holes we were allowed to drill of NBT thread, which with what type of drill press, and how to thread it, and how many terminals we were allowed putting into it. Is it dangerous? Yeah, I prefer the IECEx system fully. If an EXD equipment being modified to include additional terminals, marker, okay, if you want additional terminals and it's approved by the certificate and IOMs, go for it. You know, same size, same, you know, whatever you follow their tables. It's usually in the annex or in the conditions of use. Now, if you're doing something different, no, don't do that. It's unsafe. Call the manufacturer, ask them for their solution. We can drill into explosion proof in sight, but not flame proof. Correct. But it's not the greatest way of doing things. It causes these confusions. How to calculate free volume. That's for the testing laboratory to do. Please suggest if you may populate the weekly questions and make it a facts list for reference. Druckfest, yes, EXD, Druckfest, which I think means explosion or explosion proof or something like that. Yes, I do the sample check, the IS calc and the IS loop. See, the IS calc and the IS loop, if you don't have all the documents, you're missing all the documents from the EX register. So that simple apparatus, you need to know its entity calculations. Yeah, inductance value, capacitance value, its resistance value. Stall EX pressure. One of the gentlemen, I'll share in the chat here, hopefully. So for the one for EX pressure, guys, I got two IECEx numbers here that I'm printing out for you in the chat if you want to see it. 78U and IECEx PTB 170039X. There you go. Those are the certificates if anybody wants to check out that X pressure. It's pretty cool. There's videos for it, and we will ask Stahl if we can share the video. 2C equipment rated for hydrogen or acetylene or both. Read the certificate. If they just say 2C and it doesn't say anything else, well, then it would be rated for all the gases under 2C. But you can get 2C where it just then has bracket H2. So it's only been tested for hydrogen. Are gas groups based on minimum ignition temperature? Note, this is not the same as equipment group as stated. Yeah, so it's based on its minimum ignition energy and it's LELs and ULs. Yeah, there's many different considerations, but yeah, it's ignition energy and also its temperature class. Yeah, what gas? So it depends on what gas it is. Yeah, but usually it's minimum ignition energy. So hydrogen, acetylene, and there's another one, carbon disulfate, I believe. These are 2C. These are the most dangerous. Druckfest, pressure resistant. Thank you. Do you accept cable glands class 1 GRABCD into, well, the thing is for North American glands, some of them don't even have that type of certification. No, I would not accept American certified equipment, North American certified equipment meant for classes and divs into a zone application. But there are glands, CMP, CCG, the likes of these that are dual certified, yeah, or tri-certified. ATEX, IECEx, and also for classes and divs. Thought you might explain pressure piling. Okay, pressure piling is an internal explosion. When it happens, the waves of that pressure wave, when it bounces off a solid surface, it bounces back at even greater pressure. So as it bounces back and forth inside, it creates more, it has more energy, and it will crack the EXD enclosure if it didn't have a flame path. The flame path allows the release of that pressure, the release of that explosion in a controlled means. Thank you, William, for the question. The reason we didn't go into it, we only had so much time. EXD, there's a lot to it. The video for EX pressure is available on Stahl's YouTube channel or on their website. Okay, any more questions from anybody? Is there anybody from Stahl that would like to speak about EX pressure? I'll put it back to that screen if that person wants to raise their hand. Gergely, you want to speak? Next webinar is next Tuesday, same time, same day, every week. What is the difference between equipment group, gas group? Difference in terminology. Equipment group is now, so it's not equipment group, it's equipment protection technique. Gergely, would you like to speak? No, guess not. Okay. Thank you, everybody, for attending. If anybody from Stahl would like to raise their hand and speak, let me know. No? Okay. Yes, we will share our video via YouTube and put the post on LinkedIn. We will perhaps make reference to the Stahl enclosure, but there are other enclosures as well. We'd like to thank Stahl for their input for some of their pictures and videos today. We just wanted to give people awareness of different ideas. Standard is using equipment group as a title for gas group. Yeah, just don't get confused with that. The problem with saying the equipment group, once again, maybe one of the things with the standard, it can confuse people. For webinar link, also through LinkedIn. Yes, the webinar link will come via LinkedIn and email. Okay, everybody will receive an email with the link to this presentation. Okay, via YouTube, and it will also be posted on LinkedIn. Okay, thank you everybody for your time. If we missed one of your questions, apologies. We can only do so much. If any of you have old EX equipment, please let us know. We would love to include it in our museum. If you have something old that can join this equipment, we would gladly appreciate that. Thank you very much. One last question. How if we change a damaged bolt of an EXD enclosure with non-manufactured standard due to manufacturer not being supplied anymore? Is this okay? So if you have an old piece of equipment and the manufacturer's not around anymore, the best thing to do would be to talk to a EX consultancy such as ourselves, who can find you an EX repair shop, who would find you perhaps the correct bolt. Now the repair, sending that out for repair, that's a bit of a contentious issue. Main thing is I would have the bolt assessed by a repair shop or perhaps a different manufacturer. Maybe they bought them out, maybe they produce something similar, and would try to find a solution for that. because for changing a big control panel because of one bolt missing, I understand the issues with that. Okay, thank you everybody for attending IndEx webinar number 6 on EXD. We really appreciate your time. And should you need any services, assistance, consultation, personnel training and certification, inspections, audits, product certification, testing, we are here for you. Thank you very much. Have a good day.